Hello, everybody, and welcome back to class today. We're continuing on with our fraction journey, and this is lesson 2.44. We're going to be multiplying and dividing fractions today. And the good news is, if you found the whole common denominator thing with adding and subtracting to be a huge inconvenience, you're in luck because we're not doing that when you are multiplying and dividing. Okay, and we'll get into that in a second. So our learning targets are: I can multiply and divide fractions without the aid of a calculator. And this process looks a little bit interesting. So let's actually make sense of it by going back to geometry. And this question is prompting us to find the area of this rectangle. Once again, area is moving into two-dimensional space, and you find it for a rectangle by multiplying the length times the width. So the area is equal to the length and the width, but the length and the width are both fractions. Area is equal to 1/2 of a foot as its length times its width of 1/4 of a foot. Okay, well, I understand that a good percentage of my class might have a good idea of how to do this already. That's okay, that's great, but let's actually make sense of it by zooming out. This is, once again, this measurement says 1/2 of a foot in length and a 1/4 of a foot. So let's zoom out to make sense of this. This is the same problem, except here's our rectangle in blue, and here is 1 square foot. If you notice, its length is exactly 1/2 of a square foot, and its width is exactly 1/4 of a square foot. So what I'm going to do is just simply, that would be 1/2 of a square foot on top. Okay. So it's going to take 4 of these widths to take up the whole entire width of 1. And it's going to take 2 of these halves to make up the whole entire length of 1. And what fraction of the square foot is there? What fraction of the square foot is there? Well, it's 1 out of 1, 2, 3, 4, 5, 6, 7, 8 congruent rectangles. So I can conclude visually, just based on a visual learner, that this is its area. Here is 1/8 of the square foot. Okay, I missed that there. That should say 1 square foot. Well, actually, no, it could be measuring its length. Anyway, I got distracted there. It is 1/8 of a square foot. So let's go back to our original problem. Area is equal to 1/2 times 1/4, and the end result ended up in 1/8. Could it be that easy? Okay. How about modeling this scenario? I've got 1/2 times 1/3. And there is a good math word, an English word that translates to a mathematical operation, and that is of. And I like to think of the word of when I'm dealing with these fraction problems. So what is 1/2 of 1/3? So here on my pizza pie is 1/3 of the circle, right? 1/3 of a circle, okay, would be, I guess, 120 degrees, okay, taken up here. And I have to figure out what half of that would be, okay? Well, I'm going to go ahead and cut that in half. So that right there, this area is equal to 1/2 of a third. Okay, well, what fraction of the circle is that? Okay, what fraction of the circle is that? So I would take out my protractor and conclude that half of 120 degrees is 60 degrees. Okay, this angle here is 60 degrees. And then that this section is exactly and precisely 1/6 of my circle. Okay, 1/2 times 1/3, or 1/2 of 1/3, is 1/6 of the total. Right? So when I'm multiplying these fractions, my end product ends up getting smaller. This is interesting. So 1/2 of 1/3. The word of means to multiply. The word of means to multiply. And that kind of makes it make a little more visual sense for you, right? So the algorithm, if you are wondering, the rule to multiply two fractions is we multiply the numerators, we multiply the denominators, and then we simply reduce it, okay? And there's this other trick called cross-canceling any common factors ahead of time. That's an option. That is not mandatory. That is an option. That is not mandatory. So the rule is you just multiply across the top and multiply across the bottom and reduce. And yeah, it ends up being that easy, right? 2 times 5 on the top of this next problem, 2/3 times 5/8 is 10. And my denominator is 3 times 8, which is 24. Now, if you notice, that fraction can be reduced. 10 over 24, they have a common factor of 2. So I'll go ahead and reduce that out to make 5 over 12, and that cannot be reduced. Okay? And yeah, when I say that there's, you can cross-cancel common factors, well, if you want to make your life easier before you start a multiplicative process, before you start multiplying, you can see, okay, does 3 have any common factors with 5 diagonally here? They do not. But 2 and 8 do have those common factors of 2, so I can reduce that before I even start. Factor out 2 divided by 2 is 1, and 8 divided by 2 is 4. And we can take out the middleman here. Now we have a 1 times 5 is 5, and a 3 times 4 is 12, and we're done. So that's what that cross-canceling process looks like. Okay? So we say multiplying fractions is no problem. Top times top and bottom times bottom. You have to get the enthusiasm of a cheerleader when you say it, too. Multiplying fractions is no problem. Top times top and bottom times bottom. A nice little math rhyme to keep you going today in class. All right? So go ahead and do this example. Pause, see if we get the same exact answer. All right, and we're back. And I took the time to go ahead and cross-cancel this one first, but you didn't need to. You could make that 2 over 54, which reduces to 1/27th, or you could just go 1 times 1 on the top if you took the time to cross-cancel as I did. All right? One more geometry example, just in case I realized that the other two had just simply 1 as their denominator. Let's do one where, okay, let's do one where the fractions are not just simply having 1 as their denominator. So what I'm going to do is take this rectangle and cut it into thirds, and I want to say what is 2/3 of 1/3? 2/3 of 1/3 of this rectangle, okay? Well, what fraction is 2/3 of 1/3? So that is this section right here. Let me get out my highlighter. Is 1/3. Let's pretend that this is, since I made a rectangle, let's make this is a lasagna. This is Brooks's lasagna here, right? This is 1/3 of a lasagna, and I'm trying to take what is 2/3 of 1/3. Okay, so let's go ahead and cut this 1/3 that I've highlighted into 2/3, and then we'll find out the total fraction of this whole entire thing. Get out a different colored highlighter, and this is 2/3 of 1/3. And if you notice, what fraction of the whole lasagna has now been colored over with green? Well, 2/3 of 1/3 multiplying on the tops. Okay, 2 times 1 is 2, and the bottom, 3 times 3 is 9. If you notice, what fraction of the whole lasagna is colored green? That is 2 out of 9 congruent little rectangles, 2/9 of the total area. Okay, so hopefully that makes it make a little more sense. Go ahead, this one has fractions in it, and you have to calculate the area of your triangle. Remember, I'll go ahead and just help you out with the formula. Area is equal to 1/2 base times height. Pause it and see if we get the same answer. All right, and I have what has turned out to be a very tiny triangle here. Okay, but area is equal to 1/2 base times height, and the base was 5 inches, and the height was 9/16 of an inch. And I went ahead and I was looking for any common factors that I could cross-cancel diagonally, and I could not do that. So I had to just simply multiply across the tops. 1 times 5 times 9 is 45, and 2 times 8 times 16 on the bottom is 256. And I know that that can't be reduced because I couldn't reduce it to start from. So the area is equal to 45,256 square inches of a, or 45,256 of a square inch. A very small area taken up in that particular one. Let's go ahead and calculate the volume of this particular creature. Pause it. Let's see if we get the same thing. Okay, I'm going to go ahead and walk you through the final answer here because there is some good cross-canceling in this one. I just kind of want to walk you through that entire process. So area is equal to the area of the base. The volume is equal to the area of the base multiplied by the height for this rectangular prism. So I have to find the area of the base. If you notice, inside these parentheses, I have 3/4 times 2/3, and I have a 3 diagonal from another 3, they will cross cancel completely, turn into a 1, turn into a 1. A 2 diagonal from a 4 will turn into a 1 over a 2. So I have simplified in my parentheses using cross canceling to knowing that the product of 3/4 times 2/3 is just simply a half. And I'll multiply that times my 11/6. Remember, this 1 and 5/6 has to become that improper fraction before you can multiply. And the volume is equal to 11 on the top over 12 on the bottom, and my unit is going to be cubic feet, feet to the 3rd power. All right, 11/12 of a cubic foot, finding the volume there. Okay, so multiplying fractions is no problem. Top times top and bottom times bottom. But let's consider division. And the question that's prompting us here in our visual aspect here is how many eighths of a circle can fit into 1/2 of a circle? Okay, so essentially what this is asking is what is 1/2 divided by 1/8? That's what division is saying, right? For the same reason as saying, okay, if I did 10 divided by 2, it's saying how many groups of 2 can be made out of 10, right? Or how many times does 2 go into 10? Or how many times does 2 fit into 10? This is asking a very similar question. How many 1/8 can fit into 1/2? So let's go ahead and just split up the circle, okay? There's our half, okay? Now we've split it into quarters. Let me highlight the half just to make sure we're clear on a visual aspect. There, this top of the circle is 1/2 of the circle, okay? And let's go ahead and split it into eighths and just go ahead and count them. How many eighths fit into 1/2? Okay, so 1/2 being divided by 1/8. Here is 1, 2, 3, 4, 1/8 of our circle. Each of these are representing an eighth. And 1/2 divided by 1/8 is 4. That's interesting. So that makes sense with the circle, but mathematically, this is not as easy as simply dividing across the top or multiplying across the top and the bottom like we did in the last thing. So what's going on here? Okay, how about we do another one? How many 1/3 of a circle can fit into half of a circle? How many 1/3 of a circle can fit into half of a circle? Okay, so let's go ahead and make our half a circle again. How many thirds of a circle can fit into 1/2 of a circle? So it looks like, right, if I measure about 120 degrees here, that's 1/3 of a circle. There's 1, and this would be another 1/3. So not quite 2. How many? So if I take 1/2 and divide it by, and I divide it by 1/3, I'm looking at something that's a little harder to count. So spoiler alert, this is what is going to happen. When you are dividing by a fraction, it does the same thing as multiplying by the reciprocal. It does the same thing as multiplying by the reciprocal. So let's check this out. 1/2 divided by 1/3. How many 1/3s go into 1/2? Well, 1/2 being divided by 1/3 is the same thing as 1/2 times 3/1. And now we have something that's a little easier to deal with. Now we have 3/2, or as an improper fraction, or as that improper fraction being turned into a mixed number is 1 1/2. Okay, so 1/2 divided by how many thirds fit into half of a circle? You can kind of see right there, and I know I kind of poorly drew it and I wasn't actually using a calculator. It takes 180 degrees to make a half of a circle, so that would be this 120 degrees plus an extra half of that, okay? Plus an extra half, so it takes 1.5 or 1.5, okay? All right, so let's see if that same process works out for our previous slide. 1/2 divided by 1/8 turned into 4. Well, if 1/2 being divided by 1/8 does the same thing as multiplying by 8/1, the reciprocal of the second number, it's called the divisor, Then we are going to multiply across the tops. And 8 divided by 2 is indeed 4 over 1, or just simply 4. And that makes sense. You can see it visually, right? As does this make sense. It takes a little more comprehension of what's the problem is asking to see that, but it does make sense. There's 1 and 1/2 thirds are needed to make half of a circle. Okay, so dividing fractions is often thought as copy, change, flip. Okay, if you wanted to be a math nerd, you would say multiply by the reciprocal of the divisor, right? So copy, change, flip, or copy, change, reciprocate. The same rule applies even when there's negative signs and even when there's variables as well, and we'll get into that later in the year, okay? And we do not flip the first fraction. We do not flip that first fraction called the dividend. It does not end up being the same thing. So we just did these two examples. 1/2 being divided by 1/8 is the same thing as multiplying by the reciprocal of the divisor. The reciprocal is the multiplicative inverse. It is the number that gets multiplied by 1. So copy, change, flip becomes 8 over 2, which is 4. I'm going to rewrite, copy the first number called the dividend, change the number to the operation to multiplication, and I'm going to flip the divisor to its reciprocal. So copy, change, flip. Some people say keep, change, flip, and they're wrong. No, that's absolutely fine. You can say keep, change, flip as well. I like copy, change, flip. Copy, change it to multiply, and then we're going to multiply times 3 over 1. And the end result becomes 3/2, which is a fine answer, or you can make it 1 and 1/2 to make more sense of it as well. Okay? So there's some practice problems here with multiplication and division of fractions. Remember, multiplying fractions is no problem. Top times top and bottom times bottom. And for division, you have to copy, change, flips. We have two nice little tidy catchphrases. So pause the video, do these practice problems, and see if you come up with the same answers. Okay, we're back at it. Multiplying fractions is no problem. Top times top and bottom times bottom. All right, so I went ahead and did that, and I noticed that I could cross-cancel a factor of 2 with another factor of 2 diagonal, and my final answer was -1/3. And that makes sense. Half of 2/3, or half of -2/3 in this particular case, is -1/3. Remember, we always have to take these mixed numbers and turn them into impropers first. So that just became 11 on the top, and 3 times 8 is 24 on the bottom. And there was no chances to cross-cancel in that one. On the next one, we have a division problem, and there is a mixed number with a negative sign. So I went ahead and converted that. And if you remember from earlier in the unit, anytime that we have a negative sign and a mixed, we're putting that negative sign up in the top. And we should continue to do that just for consistency. Okay, so it's -17 over 3. And then I'm going to multiply by the reciprocal of the divisor. We're going to copy, change, flip. Copy, change, flip. Copy, and we're changing the sign to multiplication. And then we're going to flip the reciprocal, okay? It is simply that fraction upside down. So I didn't really do a good job defining what the word reciprocal was, okay? So if you want to write that down, that's a good math word. But we're going to reciprocal. Spelling in the afternoons, not my jam. Reciprocal. So it is the inverse, the multiplicative, I should say, multiplicative inverse of a fraction. That means the number that you multiply to get 1. Okay, 1 over x times x over 1 is equal to 1. Okay, multiplicative inverse of a fraction, it is the fraction flipped. It is the flip. Okay, that's what a reciprocal means. It's not the same thing as an opposite. Don't say opposite, because we have already defined what the word opposite means this year. And an opposite is an additive inverse of an integer, right? Opposite, or of any number, I guess you could say. So this is just simply a note that says when operating with mixed numbers, okay, continue to turn them into improper fractions but make sure that that negative sign, while the negative sign can go anywhere, put the negative sign in the numerator for consistency, right? Because when we were adding and subtracting, you add and subtract only the tops. So keep putting that into the top. So for an example, if I were to turn this problem into two improper fractions, I go negative 1 times 3 plus the extra 2, okay, to make it negative 5/3 on the top. And this one is going to be 3 times 7 is 21 plus the extra 4 is 25 sevenths, and we're good to go. All right. So that's actually going to do it for today. We can go ahead and skip the remaining practice examples. And then let's see if you guys have any questions. Make sure that you come up and ask me. Thanks, and have a great day.